Everyone, my name is Kevin. Group members are Jingyi, Solo, and Ling Hao, and this is our project on trends, associations, and patterns related to depression, an analysis of the NHANES 2017 and 2018 cohort. So to start off, I'd like to just start off with a basic introduction on what is depression. So there's quite a few diseases that are grouped under depression, such as bipolar disorder, seasonal affective disorder, persistent depressive disorder, and peripartum depression. However, the major one that we're going to focus on today is major depressive disorder, MDD, and so this is what usually people are talking about when they say depression. And depression is actually one of the most common mental health disorders and one of the most damaging for our healthcare system. So what is it? So in terms of symptoms, it is more than just a feeling of being sad. It is just loss of pleasure for things that you normally find pleasurable, otherwise called anhedonia. It's things like thoughts about dying or suicide, feelings of hopelessness, excessive guilt, things like disrupted sleep, disrupted appetite, general fatigue, not being able to get out of bed, and just low energy. In terms of how do we diagnose it, is very much based on the survey called or questionnaire called PHQ-9, with a whole series of symptoms, and you need at least 5 out of 9 of these symptoms to be diagnosed with depression, as well as having these symptoms affect your daily standard of living, as well as having these symptoms not be attributable to anything else, as well as having it go on for um, the long term, such as several months. So the diagnosis is definitely very clinical, so it's not super definitive. It's not like we can just have one blood test that we can do to find out if you have depression or not, meaning that there's quite a big gray area, so there's a lot of research ongoing to better understand this disease and how to manage it. So for management and treatment, there are two major options. There's the medications. For example, there's quite a few, but a big one that a lot of people hear about are SSRIs. So these are selective serotonin reuptake inhibitors, which act on the serotonin pathway, which is the predominant theory is that it's altered in depression. Additionally, there's CBT, which is cognitive behavioral therapy, which is done with psychiatrists and psychologists. So depression is really a multifaceted disease. It's not just psychological, but it's also social. There's biological aspects of it, such as genetics playing quite a big role, as well as environmental. There's quite a lot of things that go into it. In terms of prevalence, basically anyone can get it, and certain populations have higher prevalence of depression, such as teens, and additionally, women are twice as likely to be diagnosed as men. So why is depression a problem? Like I said before, if it's not caught or if it's not treated, it can progress into suicide, which is terrible. Additionally, it creates such a big burden on our healthcare system as it's so prevalent. So our aim is to better help researchers understand this disease by kind of highlighting some of the biomarkers and things that go into it, as well as create some predictive algorithms to help support decision making. So without further ado, the data set we're going to be working with is the NHANES data set, which is by the CDC. So it's data on the health and nutritional status as reported yearly. And it combines not only questionnaire data, but also laboratory data such as blood and urine tests. So the latest publicly available data set is the 2017-2018, and that's the one that we're going to be using. Yeah, so in terms of methods, we're going to start off with some data cleaning. And the figure here are just some unsupervised machine learning plots just to show that even in the higher dimensional space, it's very difficult to kind of differentiate like depressed patients from depressed individuals from non-depressed individuals. So yeah, it's going to be quite a challenging task. So yeah, in terms of our first step, we started off with exploratory descriptive analysis. So these are some basic statistical tests such as Fisher-Exact tests for binary data, chi-square tests for categorical data on parity tests for continuous. And because we have so many variables, we did bond Fermi correction with the following alpha value. Following that, we removed some sources of data leakage prior to doing machine learning and logistic regression modeling, such as the PH9 questions, anxiety medications, and depressive feelings. So with the univariate and multivariate logistic regression, we also had another step where we binned continuous variables, so separating it into 3 variables, either at the mean or above and below 1 standard deviation. And categorical variables were encoded following the statistical analysis. And again, we did a Bonferroni correction that was a bit lower just because we had even more features following encoding. And finally, machine learning analysis, we did some classification models using more simple models such as naive Bayes and some logistic regression models to more complex ones such as gradient boosting, random forest, XGBoost, and neural networks. Yeah, so moving on to our results. In terms of the data set, there were approximately 1,700 features available to us, but after cleaning, we got around 161 lab features and 286 questionnaire features. So the lab features included urine and blood samples for things such as metabolites, nutrients, blood cells such as red blood cells, and white blood cell information, and toxins such as heavy metals. And the questionnaire variables include demographics such as age, gender, weight, height, as well as medical conditions and comorbidities, diet information, social stuff, occupation, and economic variables. In terms of the data set, we had around 5,762 individuals, with approximately a tenth at 583 individuals with treated depression. So that was our criteria for putting them in the depression class, as being treated for depression was uh, very high likelihood that they have been diagnosed with depression. Yeah. So in terms of results, I'm going to start off with the questionnaire analysis. So we got quite a few features from the statistical test that were significant, and they are split up into major groups. So for demographic and social, we saw that gender, marital status, and total number of people in the household were significant. So total people, number of people in the household, we saw that the lower amount of people um, people with depression had generally lower numbers of people in the household. And similarly for marital status, people who were divorced had higher rates, and gender, like I said before, women tend to have higher rates of depression than men. In terms of diet and food insecurity, those seem to be quite prevalent with several features popping up, as well as with economic things like income, poverty index, and family income played a part, with lower income associated with depression, substance use with alcohol and cigarettes, and lastly, physical activity, which is very prevalent in the literature, showing that physical activity, being more active, lowers your risk of depression. So, if these individuals partake in vigorous and moderate recreational activity, as well as spending more time outside, they healthy individuals compared to depressed individuals had more of these features. Yeah, so moving on to lab analysis, we looked at some of the metabolites, and the first one that popped up were the beta-carotenes. So these are derivatives of vitamin A that you get from food, and literature shows that these have an inverse correlation with depression, and this is reflected in our analysis. So the lower amounts of beta-carotene, carotenines were found in depressed patients, with one exception with retinol, which was actually increased in the serum or blood of depressed individuals. Insulin was also increased in the blood of depressed individuals, but this likely is correlated with depressed patients being more complex or comorbidities such as diabetes. Vitamin D in literature, there's an inverse correlation. So we would expect depressed individuals to have lower amounts of vitamin D and its derivatives, but we actually found that vitamin D was increased in these patients. Additionally, toxins. So we found things like furan, dimethylfuran, benzene, and cadmium to be increased in the blood of depressed patients. However, mercury and methylmercury were actually lower. And lastly, the standard biochemical profile are just things that show up routinely, such as protein, your liver enzymes, hemoglobin, as well as your glucose. And these were all found to be significantly altered in the blood of depressed patients. So that does it with for descriptive analysis. Moving on to our logistic regression. So with univariate logistic regression, that was more of a feature selection step. So from those 450 variables, we got 138 variables that were significant at that alpha value. And we use these for multivariate logistic regression and machine learning modeling. So the multivariate logistic regression is actually strongly predictive of depression at an AUC, or area under receiver operator curve, of 0.855. And another metric would be an accuracy of 90%. The AUC is just more balanced when there's a significant, is a big cost imbalance where we only have 10% of our individuals having depression. And we've also included a list of some of the top features from univariate logistic regression, from multivariate logistic regression. For example, the first one, in terms of the odds ratio, if a individual has trouble sleeping, they have a 60% higher chance of having depression. So that's how to interpret the odds ratio. Yeah, so moving on to machine learning analysis, we checked quite a few models, and we actually found that gradient boosting was the highest one at an AUC of 0.87. So this is a rock curve right here, and this was the best predictor of depression. So we hope that this could help support clinical decision making using our automated machine learning model. Yeah, a few models came close, but the gradient boosting was the strongest. And yeah, that is our project. So thank you so much for listening.